Welcome. In this lecture in linear data analysis, which has multiple sessions, we'll explore the curse of dimensionality. The main concepts for this lecture are we'll explore high-dimensional data by using hypercubes. What we'll discover is that the patterns of labels of hypercubes grow super exponentially. We'll find that the volumes of hypercubes grow exponentially. We'll discover that the empty spaces in high dimensions grow exponentially, and we'll discover that if we have Gaussian distribution of data, that the tails also grow exponentially. One problem we can keep in mind as we work through this lecture is, why is working with many variables so hard? Well, this term comes from dynamic programming, and Richard Bellman in 1956, he not only invented dynamic programming, he invented the name dynamic programming, and what he was trying to do was solve large numbers of partial differential equations. He came up with the term the curse of dimensionality to try to describe some of the problems that he was seeing. His observation is perhaps one of the greatest understatements I've come across in computing science, which is that the solution is not routine. When he says not routine, I'm going to say really, really hard. So what we'll do to explore this is we'll use a hypercube. And what this is a graph in n dimensions. And the unit hypercube has various definitions. In some definitions, the vertices have coordinates that are either 0 or 1, which means the edges have unit length. In some, the vertices have coordinates that are plus or minus 1/2, which also leads to unit length. And perhaps the most common is that the vertex coordinates are plus or minus 1, which means every edge has a length of 2. We'll use this third definition. So our formalism is that these are vertices, and every vertex V has n entries, and each of these entries is either plus 1 or minus 1. And an edge connects two vertices if they differ in exactly one of these entries. And we'll go through this in an example very soon. So if we have at least one dimension, and zero dimension is always one of these problems that we're running into, is that we can actually figure out the dot product of two adjacent vertices. So small dimensional hypercubes have names, and you're familiar with many of these names. If it's 0 dimensions, we call that a point. If it's 1 dimension, we call it a line segment, specifically a unit line segment that goes between -1 and +1. In 2D, we call it a square, and this will have a lower corner of -1, -1, and an upper corner of +1, +1. In 3D, it's a cube. In 4D, it's a tesseract, and beyond that, I don't know any common names for hypercubes because we rarely go even into 4 dimensions. We can visualize these hypercubes very easily. In 1 dimension, this is a line segment. In 2 dimensions, it's a square. In 3 dimensions, it's a cube. And in 4 dimensions, I'm afraid you're going to have to go elsewhere because my 4-dimensional visualization skills are very poor.